Dear students, in today's lecture, we will learn about refrigeration, its cycles, types, principles, and applications. So let's start. Refrigeration is defined as a process in which work is done to remove heat from one location to another. Simplest form of refrigeration observed in daily life is the use of ice. All refrigeration systems are heat pumps, that is, pumps energy from a lower to high potential. The process of artificially producing extreme cold temperature is referred to as cryogenics. So refrigeration is the process of removing heat from a substance under controlled condition. It involves reducing the temperature of a body, maintaining it below temperature of its surrounding. In other words, refrigeration is the continuous extraction of heat from a body whose temperature is already lower than that of surroundings. So how heat flows in refrigeration system? According to the second law of thermodynamics, heat always flows spontaneously from a body at higher temperature to body at lower temperature. Heat cannot flow from a colder body to a hotter body on its own. There must be a temperature difference between two bodies for heat transfer to occur. So this is the main theme of second law of thermodynamics, and refrigerator work by this mechanism. And for lowering the temperature from the existing temperature, we need to work. Okay, this natural direction of heat flow is similar to water flowing from a higher level to a lower level. Just as water seeks its own level, heat naturally seeks to equalize temperature. So key points for heat transfer includes: heat transfer requires a temperature difference. In refrigeration system, a pressure difference is also deliberately created to control the direction and efficiency of heat movement. The refrigeration system operates in two main sections, that is, one is evaporator and another is condenser. So evaporator is lower pressure, lower temperature zone, and condenser is higher pressure, high temperature zone. We will discuss this in upcoming slides. So our first refrigeration system is vapor compression refrigeration system. This is the most important system from the point of commercial and domestic utility and most practical form of refrigeration. The working fluid refrigerant used in this refrigeration system readily evaporates and condenses or changes alternatively between the vapor and liquid phases without leaving the refrigerant plant. During evaporation, it absorbs heat from body, or in condensing or cooling it rejects heat to the external hot body. The heat absorbed from cold body during evaporation is used as latent heat for converting it from liquid to vapor. Thus a cooling effect is created in working fluid. So in vapor compression refrigeration system usually works by a refrigerant or CFC or HFC gas which circulate throughout the refrigerator, and in this case compression happens. Okay, mainly compression happens by compressor, and this is the main theme for vapor compression refrigeration system or VCRS. So the main principle of refrigeration, it can be categorized into two fundamental principles, that is, number one, evaporate at low pressure low temperature, absorb heat, creates cooling, and condense at high temperature high pressure, rejects heat, complete the cycle. So the two principle is, first one is latent heat of vaporization. When a liquid is converted into gaseous state, it absorbs a large amount of heat from its surrounding. This is called latent heat of vaporization. Importantly, during this process, the temperature remains constant, only the phase changes. In refrigeration, this principle is utilized in the evaporator. The liquid refrigerant absorbs heat from the space or substance to be cooled, turning into vapor. This absorption of heat produces the cooling effect. And second principle is gases gives off heat when changes from gas to liquid. This is called latent heat of condensation. When a gas is converted back into its liquid state, It releases a large amount of heat to the surroundings. This heat is known as latent heat of condensation. This is as just opposite to latent heat of vaporization. Again, the temperature stays constant during this phase change. In refrigeration, this principle is applied in the condenser. The high pressure refrigerant vapor rejects the heat which was absorbed in the evaporator plus the heat of compression to external environment and condenses into liquid. So this is the overall theme of a refrigerator. Now we can easily understand the refrigeration cycle if we focus on this. So this is compressor, this is condenser, this is the metering device, and this is the evaporator. So there is a full video lecture regarding the detailed explanation of refrigeration cycle, which will be found in this link. If you want this detailed uh, lecture, please click on this link. However, now I'm discussing this in short phase. First of all, to remember this, you need to divide this into 4 segments. Okay, so in the lower segment, the phase is always liquid, and in the upper segment, the phase is always vapor. Okay, and in the right segment, the pressure is always low. Okay, so low pressure means low temperature, and in the left segment, the pressure is always high. Okay, I hope that you have already understood the phenomenon. Now I'm dividing this into this quadrant. Okay, so now you can easily understand 4 phases. Okay, so this is the high pressure high temperature and vapor zone. This is the low pressure low temperature vapor zone. This is the high pressure high temperature liquid zone, and this is the low pressure low temperature liquid zone. Okay, so what is the function of compressor? If we begin with compressor, we will find out that uh, to compress the vapor into the vapor, but the increasing the pressure. Okay, so the opposite would be for metering device, from high pressure to low pressure. Okay, then the condenser will condense the refrigerant. Okay, so the vapor refrigerant will convert it into liquid by condensation, and the opposite would be happening in evaporator. Okay, so this is the overall thing. If you have still confusion regarding the overall cycle, please click on this video. You will easily understand this. So now let's discuss one by one. First of all, the condenser. The liquid refrigerant is kept in a container, namely condenser. The refrigerant is under pressure and the vapor and the liquid phases are in equilibrium. The purpose of this condenser is to extract the heat from the refrigerant to the outside air. The temperature of the high pressure vapor determines the temperature at which the condensation begins. As heat has to flow from the condenser to the air, the condensation temperature must be higher than that of the air. So the condenser is located on the below lower part of the refrigerator. Sometimes we feel heated whenever we lean with a refrigerator. Actually, the heat comes from this condenser. Okay, the main function of the condenser is to emit the heat from the refrigerant to the atmosphere. Okay, so the refrigerant again loses the heat and get converted into liquid. The high pressure vapor within the condenser is then cooled to the point where it becomes a liquid refrigerant once more, whilst retaining some heat. The liquid refrigerant then flows from the condenser into the liquid line. Then the expansion valve. Within the refrigeration system, the expansion valve is located at the end of the liquid line before the evaporator. The high pressure liquid reaches the expansion valve having come from the condenser. The valve then reduces the pressure of the refrigerant as it passes through the orifice which is located inside the valve. On reducing the pressure, the temperature of the refrigerant also decreases, which is called Joule-Thomson effect, to a level below the surrounding air. This low pressure, low temperature liquid is then pumped into the evaporator. Okay, so this is the main function of the expansion valve, which is just opposite to the compressor. So whenever something is passing into a pipe and suddenly expanded, then the temperature will fall. The next one is evaporator. The we kept our foods or pharmaceuticals into the evaporator. Okay, the purpose of this evaporator is to remove unwanted heat from the product or environment via the liquid refrigerant. The liquid refrigerant absorbs heat from the environment and starts boiling at a lower pressure. The level of this pressure is determined by two factors: the rate at which the heat is absorbed from the product to the liquid refrigerant in the evaporator, and the rate at which low pressure vapor is removed from the evaporator by the compressor. To enable the transfer of heat, the temperature of the liquid refrigerant must be lower than the temperature of the product or environment being cooled. Once transferred, the liquid refrigerant is drawn from the evaporator by the compressor via the suction line. When leaving the evaporator coil, the liquid refrigerant is in vapor form. So the main function of the evaporator is evaporation. Okay, so what will be evaporated? The refrigerant, the liquid refrigerant will be evaporated into vapor. Okay, this is the evaporator, and actually latent heat of vaporization, this principle will work in this evaporator. And again, the compressor, the purpose of the compressor is to draw the low temperature low pressure vapor from the evaporator by the suction line. Once drawn, the vapor is compressed and rises in temperature. Okay, so temperature and pressure is always proportional. Whenever pressure is increasing, temperature is increasing, and whenever temperature is increasing, pressure is also increasing. Therefore, the compressor transforms the vapor from a low temperature vapor to a high temperature vapor, in turn increasing the pressure. Okay, as we have already discussed, the main function of the compressor is to increase the pressure. The vapor is then released from the compressor into the discharge line. Then again, the condenser, the high pressure high temperature vapor flows into the condenser. The condenser extracts heat from the refrigerant to the outside air. The high pressure vapor within the condenser is then cooled to the point where it becomes a liquid refrigerant once more, whilst retaining some heat. The liquid refrigerant then flows from the condenser into the liquid line. So let's discuss some pharmaceutical and industrial applications of refrigerator. First of all, preservation of perishable food products by storing them at low temperature. Air conditioning of private homes and buildings. So we will also discuss this in the upcoming chapter, air conditioning. In commerce and manufacturing, there are many uses of refrigerator, like to liquefy gases, oxygen, nitrogen, propane, methane, to condense water vapor from compressed air to reduce its moisture. In oil refineries, chemical plants, and petrochemical plants, it's used to maintain certain processes at their required low temperature. Metal workers use refrigerator to temper steel and cutlery. In transporting temperature-sensitive foodstuff and other materials by trucks, trains, airplanes, and sea-going vessels, it is necessary. In pharmaceuticals, for storage and preservation of ingredients, for storage and preservation of API, excipient, finished products, etc., for maintaining temperature of the manufacturing units at desired operations temperature to reduce humidity. Now, let's discuss the most important ingredient of refrigerator, that is refrigerant. So a refrigerant is a compound used in the heat cycle that undergoes a phase change from a gas to a liquid and back. A number of refrigerants are available which permits the selection of a specific application. For example, trichlorofluoromethane. Okay, so there are some of refrigerant which are used commonly uh, in vapor compression refrigeration system. Now we'll discuss some factors which will affect the choice of a suitable refrigerant. Okay, first of all, boiling point. The boiling point of the refrigerant should be sufficiently lower than the desired evaporator temperature. Okay, so just think, we have three refrigerant. Okay, which one of them is having 50 degrees Celsius boiling point, then another one is having 10 degrees Celsius boiling point, and another one is having 2 degrees Celsius boiling point. So which one is the best? If we see, just think that in case of 50 degrees Celsius, okay, to get vaporized it needs 50 degrees Celsius. So just think, you are heating your refrigerator in 50 degrees Celsius, then what will ultimately happen? It will just explode the freeze. Okay, so obviously we don't want that our refrigerant will get evaporated into higher temperature. We never want that. Okay, so this is very risky. So it is very okay if we keep the temperature as low as possible. Okay, we keep the boiling point as low as possible. So boiling point should be sufficiently lower. It is highly desirable to maintain the operating pressure above the atmospheric pressure. So another concept is why the operating pressure should be high. Okay, first of all, operating pressure means this is your refrigerator. Okay, it will work under a sub pressure. Okay, it has a pressure within it. This is the operating pressure. Just think, if this pressure is higher than the atmosphere, what will happen? Air will go from here to there. Just think the opposite thing. Suddenly the atmospheric pressure is higher. What will happen? The pressure will go from higher to lower side. Okay, then the air will come from outside to the inside of the refrigerant. Okay, then whenever you are just opening your fridge, then air and other dust will just get enter into your refrigerator. So this is very risky. So we always want that our inner pressure will always be higher. Okay, this is also as same scenario as the clean room. We know in the clean room area the pressure should be very higher. Okay, otherwise there would be ingress of dust or other ingredients into your clean room area. So this is the same concept. This prevents air and moisture from leaking into the system, which can cause corrosion, ice formation, and reduce efficiency. So next one is freezing point. So let's think about uh, a scenario. For example, one component is having freezing point 5 degrees Celsius, another refrigerant is having the freezing point of 0 degrees Celsius, another one is having the freezing point of minus 20 degrees Celsius. Now which one will we select? Just think, the refrigerant which is getting freezed in 5 degrees Celsius, or which freezing point is 5 degrees Celsius, will easily get freeze whenever freeze temperature is getting into 5 degrees Celsius. We never want that, because sometimes we need to convert the water into ice, okay, in our refrigerant. So then what will happen? Our overall refrigerant will get freezed. We never want that. Okay, and for that reason we should keep the temperature or the freezing point as much lower as possible. Okay, just think, one component is having freezing point minus 20 degrees Celsius. Okay, so it's very difficult to reach this point. That means it's very difficult to reach um, to freeze the refrigerant. So freezing point must be well below the lowest operating temperature of the system. If the freezing point is high, the refrigerant may solidify inside the evaporator coil, causing blockage and system failure. Now, critical temperature and critical pressure. We always know critical temperature and critical pressure are those temperature or pressure below which a liquid will be in liquid phase, or above which, above the critical temperature, obviously the liquid will vaporize, and this is the critical temperature. Obviously in all of the cases the critical temperature and pressure will be lowered. Okay, the operating temperature and pressure of the system must remain well below the critical value to ensure easy liquefaction of the condenser. Above the critical temperature, the gas cannot be liquefied no matter how much pressure is applied. So latent heat of vaporization. A high latent heat of vaporization is preferred. High latent heat means more heat can be absorbed per unit mass of refrigerant during evaporation, resulting in greater cooling effect with smaller refrigerant circulation rate. Then condenser and evaporator pressure. The condenser pressure should be as low as possible to reduce the mechanical strength required for the compressor condenser piping. Lower pressure allows the use of lighter and cheaper equipment. The evaporator pressure should not be too low to avoid air and moisture ingress. Specific volume. The specific volume of the refrigerant should be low. Low specific volume reduces the size of compressor and piping required. Then the viscosity and thermal conductivity. So we never want that our refrigerant would be viscous, and the viscous material will just hinder our flow of refrigerant. Okay, so low viscosity improves the flow characteristics and reduce pumping power. High thermal conductivity ensures better heat transfer in the evaporator and condenser. Then chemical stability and compatibility. The refrigerant should be chemically stable at operating temperatures. It should not react with compressor coil, metals, or gasket used in the system. It should be non-corrosive to avoid damage to system components. Then safety consideration. The refrigerant should be non-toxic, non-flammable, and non-explosive. It should have global warming potential (GWP) and zero or very low ozone depletion potential. Cost and availability. The refrigerant should be economical and easily available in the market. The cost of refrigerant charge and its replenishment should be reasonable. Oil miscibility. Good miscibility with compressor lubricating oil is desirable for proper lubrication and return of oil to the compressor. So now it's time for discussing another refrigeration system, that is vapor absorption refrigeration system, that is ARS or VRS, a type of refrigeration technology that produces cooling by using heat energy instead of mechanical work, that is in vapor compression system. The basic working principle involves the absorption of refrigerant into a suitable transport medium followed by its separation using heat. So working principle is the refrigerant is absorbed by a liquid adsorbent to form a solution. This solution is then heated in a generator to release the refrigerant vapor. The refrigerant vapor then follows a cycle similar to the vapor compression system. It condenses, expands, and evaporates to produce the cooling effect. The absorbent is recycled back to absorb more refrigerant. So we know these components are as like as the refrigerator, but this is different. Okay, this is just in place of compressor. So we know in the condenser usually we know the heat goes into the environment and the refrigerant converts into liquid, and within the expansion valve it uh, converted into low pressure low temperature liquid. And in the evaporator we know the we keep our pharmaceuticals or food products in the evaporator, and here the refrigerant takes the heat from this evaporator food products and convert it into vapor. Okay, so this is the pure vapor which is entering into the absorber, and in this absorber what is happening, it get absorbed into water. First of all, ammonia will be get absorbed into water. Okay, then this absorbed water which will get mixed with the pure ammonia will produce ammonia solution. So this is a weak solution. Okay, this will to make it a stronger solution, what we need to do, we need to provide heat, and this heat is provided by solar energy. Okay, so this is a generator which will produce heat, and whenever it is being heated then it will be strong solution. So this is the overall scenario, and our pure ammonia is get heated, and generator is producing the heat, and by producing the heat we know that our temperature will increase, and whenever our temperature will increase then our pressure will also increase. Okay, and that is how pure night ammonia, which is a low pressure or very weak solution, will ultimately get converted into very strong solution with high temperature and high pressure. This function is as like as compressor. We are just using absorber and generator in place of compressor, and this is the basic difference between the compressor and generator absorber. Okay, because a compressor has a lot of problems. Okay, what are the problems? Because it increases the price of the compressor is very high, then compressor guarantee warranty is so much lower than that of absorber or VRS. Then compressor has a limited capacity, we know. So these are the limitation of vapor compression refrigeration system, and that's why we use absorber and generator in place of compressor, and that's why this system is called vapor absorption refrigeration system. So we have seen here that we are just using the heat. nothing else. We are just using the solar energy heat, and this heat is converting is providing high temperature, and this high temperature is just providing high pressure. As we know, PV is proportional to nRT. Okay, PV, we know PV is equal to nRT. Okay, nRT. Okay, that is P and that is V. Okay, so whenever T is increasing, pressure is also increasing. Okay, so this is the main phenomenon. So these are the common absorption system, as we have already discussed, that one is ammonia water system, which is most commonly used, and it is suitable for both cooling and refrigeration applications. Then water lithium bromide system, uh, it is commonly used for air conditioning and chilling applications. Cannot be used for sub-zero temperature because water freezes at 0 degrees Celsius. Then water lithium chloride system, that is water lithium chloride, similar to water lithium bromide system but uses lithium chloride as absorbent. However, there are some limitations of vapor absorption refrigeration system due to their lower efficiency, high cost and larger size. Absorption refrigeration system are not suitable for small domestic application. They should be considered only when cheap or waste heat is abundantly available, electricity cost is very high, silent operation is required, then large cooling capacity is needed. So however, these are used in these sectors: chemical plants, food processing industries, cold storage warehouse, district cooling system, then hotel and hospitals. So this is the most important part and overall summary of this chapter, and it is also an important question for examination, that is the similarities and differences between VCRS and VRS. So let's start. Basic principle: it works by compression, it works by absorption. It uses electrical energy, and we have seen it uses solar energy, okay, or heat energy. Then major components are compressor, condenser, expansion valve, evaporator, but its major components are somehow similar. The main difference is compressor. Okay, in place of compressor, absorber and generator. The noise level, it's noisy because of the compressor and it's very quiet. Then coefficient of performance would be high for this because it's a uh, refrigerator which use refrigerant like CFC or HFC, but its performance is lower. Then refrigerant use is CFC, SCFC, HFC, and in that case we have seen ammonia water. Then operating pressure is high pressure in condenser, but it has low pressure. Initial cost is lower, then its cost is higher, but running and operation cost is very higher for VCRS, but it's for lower for VRS. Then maintenance is higher for this, and for VRS it is lower. Then cooling effect is fast because it's a single refrigerator, but it's low. Okay. Then suitability for capacity, small to very large scale capacity, but it is always used for large scale capacity. Then part load performance good, but for this it is poor. Then space requirement is compact, but it requires more space. Okay, we know it's very much larger in size. Then environmental impact depends on the refrigerant, but it's generally better than that VCRS. Then best application is domestic refrigerator, air conditioner or commercial chiller. Then its use is in industrial cooling where waste heat steam is available, factories, power plants, solar cooling. Then efficiency, it is more efficient when electricity is cheap, but it is more efficient when low grade heat is available at low cost. So these are the overall summary of our refrigeration system. In that chapter we have learned about different types of refrigerator, principle of refrigerator, then uh, overall instrumentation and working principle of refrigerator. However, if you have any confusion, please inform me in the comment section. Thank you.